Hello and welcome to this second film in the series about the mole and mole calculations. This one's called Moles and Particles, and the idea of it is to teach you how um, to use the idea of a mole to talk about how many particles you've got, or if you've got a number of particles, how you can find how many moles you've got. So in order to do this, we're going to introduce some symbols. So hopefully you're going to know some important symbols that we use when we're talking about moles and particles, and hopefully give you a little bit of practice into converting these things. Okay, so here are the symbols. Okay, little n to start with. Okay, this is the number of moles. All right, so how many moles I have. Remember, one mole is the amount of substance, or a mole of a substance is the amount of that substance that contains Avogadro's number of particles. So I could have a mole of apples, I could have a mole of carbon atoms, I can have a mole of anything. Okay, N, with a capital N that is now the number of particles, and capital L, that is this number 6.022 times 10 to the 23, so that's Avogadro's number. So remember those symbols as we move through this film. We're going to be using them, we're going to be converting one into the other. Okay, there's various formulas that you will need to remember, or perhaps not even remember, perhaps you'll be able to figure them out yourself. Okay, now here we are. If I had 2 moles of a substance, right, how many particles do I have? Right, now what's this question asking? This question is asking me to say how many particles are there. So the number of particles equals, okay, this is going to be in some way related to the number of moles. Okay, now if I said to you there were 10 particles in a mole, and I said to you you had 2 moles, then you'd probably be able to tell me you'd had 20 particles. How would you find that? Well, you've just taken the number of particles that I've told you there are in a mole and multiplied it by 2. Okay? In actual fact, there's 6.022 times 10 to the 23 particles in 1 mole, and we call that Avogadro's number. But you'd still just double it if you had 2 moles. So you know that if I ask you the number of particles, you're taking the number of moles, which is 2 in this case, and you're multiplying it by the number of particles in a mole. So there's one of the relationships that we need to remember, that the number of particles is equal to the number of moles times Avogadro's number. Okay? And once you know that, if you're good at rearranging things, you can also find a formula for little n, the number of moles. And that's just n divided by Avogadro's number. So the number of particles divided by the Avogadro's number is equal to the number of moles. So there's 2 relationships that we're going to use quite often. Okay? Some people like to see these things in little triangles. Okay? And these 3 things, or those 3 things, can be put into a triangle by saying, right, okay, well, if we put capital N up there, then n times L is equal to n. So if by covering up one of the things that I want to find, the triangle tells me what the formula is for it. Okay, if I want to find little n, that's the number of moles, I cover it up and it says it's big N over L. Okay, so if you don't like rearranging expressions, you can remember one of those triangles. You could alternatively just learn the formulas. Okay, or you can just say to yourself, right, well, I can figure out what one of the formulas is just by common sense. And then I can get another formula from that, and I could even construct a triangle out of those things. But anyway, how you do it is up to you. Make sure you know what the relationships are. Here's a couple of examples of how we use these things. How many particles are there in these 2 amounts of stuff? Okay, how many particles is asking find big N. Okay, and as we saw, this is number of moles times Avogadro's number. Well, here I've got 10 moles, so the number of particles will be quite simply 10 times 6.022 times 10 to the 23, which hopefully, if your standard form is good from maths, is 6.022 times 10 to the 24. Okay, but you can always plug that into your calculator, you don't have to do it in your head. 0.025 moles of water. Okay, let's just rub that whole thing out. Okay, let's start again. 0.025 is here the number of moles. Okay, I know that big N is equal to the number of moles times Avogadro's number, 6.022 times 10 to the 23. Okay, plug those numbers into your calculator and you find that you get approximately a 40th of 6, okay, times 10 to the 23. But anyway, you can plug those numbers into your calculator and see what you get. Okay? So that is using the formula for the number of particles. Big N equals the number of moles times Avogadro's number. Okay? Moving on here, how many atoms are there? Now this seems like a similar question, except we need to be a little bit careful here, right? From our knowledge of ionic compounds and all the ion list and the covalent compounds as well, we should be able to figure out that the formula of sodium chloride is NaCl. The formula of water, that's H2O. This is now not asking us how many particles there are in 10 moles of this thing. So there's 10 times 6.022 times 10 to the 23 sodium chloride particles in 10 moles of sodium chloride. But notice there's 2 atoms in a particle of sodium chloride. Okay, so to find the number of particles, I've got to find how many atoms there are in a particle first. Remember that number of particles is number of moles times Avogadro's number. So this would be 2 times 10 times 6.022 times 10 to 23. Okay? And in this case, I've got 3 atoms in one particle, so 3 times 0.025 times 6 times 10 to 23. I've just rounded that there. Okay? And all these things can be done on your calculator. All right? So remember, if you're asked about atoms in a substance rather than particles, be a little bit careful because there might be more than one atom in a particle. Moving on. How many moles are there in 600 atoms of sodium chloride? Okay, this is a bit of a bad question because it should say ions here. Okay? Right? If I have 6,000 ions of sodium chloride, I have, remember, sodium chloride is NaCl, so I've got 3,000 particles of sodium chloride. Okay? If I'm asked to find how many moles there are, I'm saying number of moles is big N over L. Okay? So it'd be 3,000 over 6.022 times 10 to the 23. And again, that's something you can do on your calculator. Okay, if I had, this seems like a stupid number of molecules of water, but as we'll see, it's not that ridiculously large if you're talking about moles of things. If I've got a million molecules of water, I've got 1 times, in actual fact, times 10 to the 30, because there's 6 there, 10 to the 6, 10 to the 6, 10 to the 6, 10 to the 6, so 5 10 to the 6s is 10 to the 30. The number of moles of water is quite simply the number of particles that I've got divided by 6.022 times 10 to the 23. We could do that on our calculator. It's going to be approximately 1/6 times 10 to the 7. So that's not that big a number of moles. This is about 1.5 million moles. Okay, that seems like a ridiculous number of molecules, but as we can see, number of moles is not that big. So that's why the mole is really good for counting atoms and molecules, because it turns things into sort of manageable numbers. Anyway, now that you know a bit more about the mole and what it means and to do with particles and things like that, we're going to move on now to what molar mass is. Okay, so that would be a good film to watch next. It's called Molar Mass and Percentage by Mass.